Nadine, and I will be discussing Lab 1, Constant Velocity for Physics 2211. So, just to give an introduction of what we did for lab and what was our purpose. So the purpose of this lab was to observe an object's position while it is traveling at a constant velocity. So this just means that the object is not accelerating and it is moving in a straight path. We also had to understand Newton's laws, specifically the second one, which was the momentum principle, and then we could take all that we gathered and compare our experimental versus our computational model. And this would allow us to just look at where the object was and what our predicted results would be. Materials used were an expo marker, and this was just our object/system. For our software, we used Tracker, and Tracker allowed us to observe different durations that the marker moved. Then, with that information, we could attach our final velocity/initial velocity and add that to GlowScript, and this allowed us to look at our predicted values. As well, I used Excel, and Excel just helped graph both models onto one single graph. So, Newton's first and second laws of motion, the first one being an object at rest will stay at rest unless acted upon by an external force. And an object in motion has the same thing going on. It won't change unless an external force is exerted upon it. So this just goes to show that our F net, if it equals 0, means that our final velocity will equal our initial velocity. When it comes to the second law, force equals the rate of change of momentum on an object with respect to time. Basically meaning that our net force will equal the change in position over the change in time. Or you could break it down and you could find our velocity update formula, which is listed in the bottom right corner. Okay, for our experiment setup, we had to record an object moving in a straight line, which was the expo marker, and observe it at a constant speed. Once that was prepared, we uploaded it to Tracker and adjusted the video to fit the coordinates and just the time duration that it needed. Once that was set up, we took upon the center of masses and stamped it on the object as it was moving to track the timed intervals. Once those results were concluded, we then took our final velocity and went over to GlowScript where we manipulated the code, and this allowed us to create our predicted computational model. With those results, we could then graph our position versus time for our experimental and our computational data. This was then prepared to compare the model/graphs. Okay, for our observed position, this is what was recorded during our lab experiment. As you can see over here, it shows the time, and then here is the different positions that the object went through. This isn't necessary for this lab, but as you can see up here, it shows an almost linear line. This means that we could assume that our object was moving in constant velocity. For our analysis, it was noted that the time duration was 1.1 seconds, and our initial position for the object was 0.03716 meters, and then our final position was 1.02 meters. To calculate our constant velocity, like we said in the beginning slides, we noted that our final velocity was going to equal our initial velocity, which is just equaling our average velocity. So this can be set up as the change in position over the change in time. And once I plugged in those values, I ended up with the velocity being 0.893 meters per second squared. With that value, we could go back into GlowScript where we could manipulate the code and alter it. So as you can see, the position was included, as well as our velocity, which was what we calculated. And our delta t being 1 over 30 was just taken up from Tracker, and the number was just listed. Time was also changed to 1.1 because that was the duration, and our F net was set at 0. And then we also included our position update formula and our velocity update formula. Once we ran the program, this was the graph that we got, shown on the left side. So on the top, we have our position versus time. And this is just showing that the object was moving in constant velocity throughout the whole duration, as well as what's shown on the bottom graph, where our velocity has not changed at all throughout all the times of the object moving. This just goes to show what our constant velocity predicted table would look like. Moving those results to Excel, I listed out the values for our experimental model and then our predicted computational model. These values were then plugged into one single graph so we can compare the differences. So the orange shows our observed and the green shows our predicted. As you can see, our observed isn't 100% straight or linear. It's close, but not enough. Predicted was what we wanted. So to explain this, there could have been some errors. Errors such as the first two that are listed could have been human errors. So for one, the video that was recorded. The video being that the marker wasn't placed accurately in a straight direction as noted with the coordinates. Let me go back. Right here, as you can see, the marker isn't accurately straight. So for me to plug in the coordinates, I had to do my best with what I thought was the straight, or a straight coordinate line. And other errors could have been the position tracking. So when we were placing the center of masses, which is just these little red diamonds, they couldn't have followed a perfect, flow. Like some could have been higher, some could have been lower. And other things to note are external forces such as air resistance and friction. Okay, what ifs? What if the axes were flipped? Well, everything would still be the same considering our values. The only thing that would change would be our slope. It would become negative. And can we determine that the number of forces incorporated together exert a 0 F net on our observed? Well, technically, no. We can't assume that because for 0 F net, our external forces such as friction and air resistance and other forces that are not noted would have to cancel each other out. And this can't really be depicted. And knowing that, these external forces could have definitely altered our system. Okay, and that's it. Thank you so much for your time.